We have created an IK setup, and now we're going to blend between IK and FK. There are quite a few ways we can approach this, and we'll take a look at a couple of them. First, we'll need to build our FK, however. I'll start this by copying our controls setup. I'll attach this at the end of the network after my IK. I'll rename the node to attach leg IK. We can then select this node and clear out the controls. The FK will only need one control. We can then select the points for our legs. We'll want 3 points from the legs, basically all the joints from the legs except the effector. I'll then replace the first 2 letters with the wildcard so that we can select all the leg joints. I can then set up the FK control we made. This control is the FK rotations control. I should now have FK controls attached to all the leg joints apart from the effector. I'll then get a visibility node. I'll set the visibility group to use the FK controls, and we'll set it to hide unselected. I will, however, bypass the visibility node for now. We can then get a rig pose node. This will allow us to pose our FK joints, and what we've created here is a perfectly viable way of setting up an FK and IK in KineFX. In this case, we've got the FK solver being calculated after we've calculated the IK. There are some very interesting applications and some big advantages to being able to do this easily, but we'll not be using this setup for this rig. Instead, we'll be working with a more traditional IK-FK blend. So we'll connect our FK to our center of gravity control instead. The center of gravity control is essentially an FK control in any case. We could create our FK controls before it, but this would be redundant. So the next thing which we want to do is blend between our set of FK legs and the set of IK legs. There are a couple of ways we can do this. One of the possibilities is to use the blend shapes node. Personally, I don't think using the blend shaped nodes on a rig is the best idea. While we can use this node, and there are some circumstances where it will work, there are a lot of drawbacks to using blend shapes for the rig. So just to illustrate what can go wrong with this node, I'm going to pose my leg so that the leg is stretched out away from the character's body. This will be done with the IK. I'll then pose the rig with the FK. We'll be dealing with the same leg. However, in this case, I want this joint to be curled inwards towards the body. So I've created my shapes, and I can now blend between them. There are some big problems with this blend. The first of the problems doesn't actually come from our blend node setting. This is actually a problem which comes from the joint orientations, and this was discussed when we were setting up the IK. So we can try and examine the orientations for the leg. With the IK I have a positive Z. It is however very difficult to make out which way the y-axis is pointing. So I'll get a null so I can look at the result more clearly. With the FK I've set up a negative Z direction. But if we take a look at our IK, we'll see that we have a positive Z direction. So I'll enter my solver, and we'll look at the IK solver itself. So I'll change the Z to be negative, and I'll set the Y to be positive. I can then exit and try my blend again, and the blend is now working correctly. So while the blend is better, we still have some major problems. I'll stop the blend halfway through so we can examine these more closely. What we'll see here is the blend is actually changing the length of the bones. And this is a fundamental problem which you'll have with the blend node. The reason for this is these blends are all linear transforms. While there are plenty of uses for this, using this on the bones will always change their length. And this is not a good idea because it is an uncontrolled change of length. So instead we'll take a look at the skeleton blend. Of the native blend nodes, the skeleton blend is the best one to use. You'll see right away that we have a correct blend between the IK and the FK now. The reason this node works is that it is blending between the local transformations. We can also use global transformations with this node, and we can do this by activating world space. However, doing this would give us the exact same problems as the blend node. So we're essentially going to blend it the same way as the skeleton blend, but we are not actually going to use either of these nodes. There are two reasons for this. The first is I like to keep the nodes as light as possible, and I don't need the extra functionality for the skeleton blend node. The second is it's a good idea to understand how the nodes actually work. So we'll get a rig attribute VOP. The FK branch will go into the first input, and the IK branch will go into the second input. I can then enter the node. I'll get a set point transforms to set our values. We'll be working with all the transforms, and I'll get a get point transforms for that. I'll set this to select everything. I'll then duplicate it, and I'll set the second node to use the second input. We'll then get the blend transforms node. I can plug in the transforms, and I will get an error that pops up. This error is unimportant. It is related to using matrix arrays as inputs. Once the nodes are properly plugged in, it will go away. And now I'll have a basic blend. But as you can see, this is going to be a world space blend. This is going to remain as a standard linear blend. And this is going to give us all the problems of a linear blend. So to get this to work properly, instead of using the global transforms, we need to use the local transforms. We can now blend with the local transforms, which will give us a correct result. And that will be our basic IK-FK setup. In the next video, we'll update this setup further and we'll add IK-FK matching.